welcome to Lights Out. I'm John Weiss,
I'm Andy Henderson.
and this is a show all about how today's latest and greatest technologies are redefining and reshaping tomorrow's industry. So, Andy, there's a lot happening in the industrial landscape today, as you well know, from supply chain risk mitigation to revenue diversification as companies look at new ways to bring in money through fill in the blank as a service, things like this. Supply chain visibility, especially now that we're facing the pandemic. And there are many, many industries when we talk about industry as a whole that are really important today when it comes to these technologies, from oil and gas and utilities and power gen facilities to manufacturing and really everything in between. Looking specifically at manufacturing, I like to talk about this one because the growth here, when we look at emerging technologies, is huge. From $1.6 billion invested in 2018 to a projected $12.4 billion by 2024. Massive growth. And obviously you're an expert in this space, Andy. Would love to get your take on the significance of manufacturing in industry, but also the importance that it has in today's economy.
Yeah, thanks. Manufacturing is near and dear to me. One of the stats that I always like to throw out there is that, and this comes from NAM, the National Association for Manufacturers, and it's that for every $1 spent in manufacturing, there's another $2.74 that's added to the economy. So it's a multiplying effect. So meaning we invest in a piece of technology for manufacturing that's going to turn around and have a larger dollar impact elsewhere within the greater economy. So therefore, manufacturing is extremely critical to things like our economic output, which there's lots of studies out there that will equate that to quality of life. So there's an argument to be made. Investing in manufacturing is investing in people's quality of life. So there's a strong set of reasoning for why we should be thinking and talking about manufacturing.
And it's not just shop floor applications, right? It's not just bridging the gap between your SCADAs and your MESs and your historians. There's a lot more to it. It's also about bringing new connected devices and products into the market. It all starts in manufacturing, right? It has to get built somewhere before people can plug it in at their house, if you will. So that's a huge market in and of itself. $500 billion is essentially the market for connected devices and connected products. That's going from 500 billion to nearly 700 billion over the next few years. Huge growth. People are all about connected products, connected devices, not just in the industrial space, but also the consumer space, of course.
For sure. All the way from my coffee pot that I can start remotely, to my washing machine that tells me that on my phone when it's done, to my car that I can crank remotely. It's all one big connected ecosystem of things, just like the name would suggest, right? Kudos for the folks who came up with that title, the Internet of Things.
Yeah, that's right. And it all starts with a bill of materials in a plant somewhere, right? And we have to now put new radio waves or radios into devices. We have to support new protocols. There are so many things that are changing in the way that we build products today. So I just like to throw that out there, because a lot of times when we talk about industry and IoT and analytics and things like this, I think a lot of people just automatically think about shop floor applications and connecting the factories. But there's actually about a 50-50 split. It's a very, very tight race when we look at manufacturing, of where the investment and technology is being deployed. And actually, it's only about half of the time inside the four walls of the factory. The other half are outside. whether it's on industrial assets going out to the field or what have you. So just some food for thought.
To the point about it doesn't start on the factory floor. I mean, when you think about the value chain for making any product at all, you can think about it from the equipment that extracts the raw materials from the earth, to the equipment that processes those raw materials, to the equipment to into say a material that is cast or forged, to the manufacturing shop floor, to then to sell those to the consumer, direct to us, the consumer, or even the consumer, the customer in that case, maybe the mine site that buys the equipment that keeps this whole cycle going.
Right.
So again, it's all a really interconnected world, and
all parts of it are touched by this technology, even at the lowest and quite literally deepest levels of a mine, for example. We have these new private networks that are spun up, companies like Rajant and other companies, right, that are actually putting communications way deep inside mines that now let us collect information off of those assets in real time as they're drilling, meters and meters deep in the earth, where we typically would not be able to retrieve data from that. It used to not be possible. Now it is.
yeah. And so it's interesting when you say things like 50% of the connected IoT devices are outside of the are the products that are going out to the customers. They're also going back into this supply chain that exists, this sort of this circular life cycle of products and components that get made.
Yep. Totally agree. That's why a lot of times I talk about IoT or emerging technologies as an ecosystem, because it's really not a linear progression or any kind of linear type model, if you will. It's really a lot of things happening at once that are all interconnected in many ways, or they have an impact on something else within that ecosystem. It's a really interesting dynamic.
So another thought, John, are you familiar with the Gartner's the hype curve?
Yeah, the hype cycle.
Yeah.
Yes, where we have kind of the peak of expectations that are ultimately unrealistic, that then dip way down into disillusionment because we're all upset with what we couldn't do, and then at some point we balance out into where we actually can be productive.
Exactly. Yeah. Where I'm going with this is that people in manufacturing or in a lot of these industrial settings, yeah, they do adopt new technology, but nobody wants to be the first one there. They want somebody else to have tested it and tried it and failed and learned and improved before they get into it. And so a lot of these technologies have been around for a little while, but they are to the point where they're industrialized now, and they are ready to go into the hands of the people in these companies, the operators running these operations.
That's a good point. It's definitely been around a while. You and I have been doing this since before it was cool and before it was called the Internet of Things, right? So we were doing it. We were just helping manufacturers become a little bit better at what they do, but now it's a trend.
I was having a conversation with a colleague yesterday, looking at I shared an article from an MIT professor who was talking about human machine symbiosis, and he was basically talking about humans and AI working together. And that was an article from the 1960s. And then you think about Alan, specifically on the topic of AI, because that's something that's near and dear to me. Alan Turing was he was one of the early thought leaders in the artificial intelligence space and developed what we know now as the Turing test, and that was back in the 50s. But then there's a subsection of what I would consider artificial intelligence that goes back to Thomas Bayes, who was a Protestant priest in the 1700s. So these really are ideas that have been around for a while and picking up steam today.
I think whether it's music, clothing, any element of pop culture or technology in what we do, even manufacturing trends in many ways, a lot of things seems to repeat itself in the world, right? And I think technology is not excluded from that trend. What we see, of course, is that we get better every time we do it, and technology becomes more and more mature, and it can do more and more with less and less, which is what's really exciting. But some really interesting themes here too. You know, you mentioned just when it comes to adoption, people want other people to go first, fail fast, try some more things, figure out what's going to work, and then once one of my peers succeeds, I'll go ahead and try it over here in my factory too. And that's a really interesting thing that you mentioned, because it creates this not only chicken before the egg kind of environment, but it also hinders, I think in many ways, the advancement of some of these technologies, because organizations are a little apprehensive to grab on with both hands and say, yeah, let's try this thing and let's roll it out. Um, what I've seen too on the same thread, and I'd love to get your take on this. I've seen a pattern talking with very large companies, Pfizer, 3M, Procter and Gamble. I've had this discussion with a lot of really, really big manufacturers where even the big guys are afraid to get into this space using some of the newest technologies, because they have this idea that it's going to take $1 million to dip my toe in the water, no matter what. And I was at a seminar with a bunch of these folks, a workshop, and I'm not sure where they got the $1 million estimate from, Andy, but every single person referenced $1 million like it's the silver bullet to solve the emerging technologies budget number, right? But it was all, I can't do this. I don't have $1 million to spend. And I heard that throughout the entire workshop. But from my perspective, I don't think that this is unattainable technology, not anymore. And I don't think you have to have $1 million budget to come use some new technology. Anyway, let me stop rambling. But what's your take on that?
Yeah, I think, and you know, we could get specific. People might say, well, it depends depending on the type of technology you're talking about. Yeah, sure. Kind of, sort of, maybe not really. It all comes back around to and I don't want to sound I don't want to sound like I'm belittling it, but this mindset of Eric Ries, the guy who wrote the lean startup, was the really popularized this idea of starting with a small, minimally viable product, and testing to prove or disprove some hypothesis, and then pivoting or persevering depending on what you learn. And from that spawns the phrase, think big, start small, scale rapidly. And I think that's the approach to any new technology, is to think about how it can make a significant improvement, figure out where you can start small to learn and test, and then with the intention that once you prove and find the value, that you're going to get behind it and scale with a rapid speed, at a rapid pace.
Totally agree. It all starts by getting a quick win and proving internally to the stakeholders, to yourself, to your executives, that this is worth investing in. But I think to get to that proof point, you don't, that doesn't have to be across 5 factories. It doesn't even have to be all across one factory. It can be one line, one piece of equipment on the line, right?
Can you think of a specific example, John? Maybe, and you don't have to name names, but something that's tangible for people to think about.
This is something, to be honest, that I come across very, very, very frequently. I almost want to say every day, but the reality is, I come across this a lot in my day job, if you will, when I'm working with industrial companies to help them adopt new technologies. Most folks will start with a really big concept, and which is good. Think big about how you can make a big impact. The problem is they want to do it all now, and
Mhm.
typically we don't have the budget to do it all now, right? Because then it does kind of become a very large investment. Maybe it is that $1 million number, I don't know, but it's very different to look at it in the sense that, okay, I need to increase OEE for this entire facility in one swoop of a project
Yeah.
versus I'm going to pick a machine and I'm going to increase my OEE on this palletizer or on this CNC machine, whatever it may be, right? Prove
Mhm.
out that the technology works, and then let's spread that out to a line and then to a few lines and then maybe to the entire factory.
Yeah, on that, I've worked with a couple of companies. One company said, um, we're going to go, this was a very large manufacturing site, brownfield, so not new. And they said, we're going to go collect data on everything because data is so important to have. And the cost of laying in the infrastructure, the cabling, the switches, all the all the other networking and servers that had to be put into place to support this came to the tune of $8 million, right?
Wow.
In that ballpark, and that's just to connect the pipes up and get the data flowing. That doesn't actually solve your problems in operation. So the thing that I always like to say is go into an area, exactly what you just said, prove the value out, then you use that value. You should get a payback on your investment from doing that.
Yeah.
And whatever additional value you got not only justifies but can offset the cost of going into the next one, and this can keep scaling up in that way. So
I think it's the only way to do it effectively, for a number of reasons. But I love what you said, Andy. Think big, start small, right? Scale efficiently. Something. I think that's what I'm paraphrasing now, but I think that's what you said.
rapidly, efficiently, yeah.
Okay,
It's
I'm close. That's great. Great topic. Um, so what I see happening in, just because we're talking about factories and manufacturing, just a few things to point out what I'm seeing from an adoption perspective. I think folks are largely focused on general process optimization, excuse me, when it comes to factory implementation, shop floor implementation. So general process optimization. Um, Visualization of the data. You made the point and told the story around all the data collection that was happening, but how do you view it? How do you determine what's important? That's something that people still struggle with, right? How do I see it is a bit of a commodity these days, but how do I derive actionable insights from all this data? That's something that's really important to manufacturers. And last but not least, the third one is condition-based monitoring. So being able to remotely view and monitor exactly what's happening right now in my process. Those are three things that I see that manufacturers and really industrial companies as a whole across the board are really focused on. Does that line up with what you're seeing in the market?
It does, and what's interesting is that I like to challenge some of those. When someone says, "I want to see what's happening right now inside of my operation," why do you want to see what's happening right now? Um, I've always been on the side of saying people want to be able to go do their jobs, and they really nobody wants to sit in front of a screen and watch to make sure that the numbers are coming out the way they expect them to, that the OEE is currently sitting in a place where they want it to be, or the parts or the throughput numbers are where they want them to be. They want to know, what they want to know is that if something is going to change those numbers, meaning there's going to be an issue that comes up that causes those numbers to, in the case of throughput, decrease. And that's not necessarily having a dashboard that shows that, but there's a call it an expert AI or an AI system, whatever you want to call it, running in the background that is that's looking for those trends or patterns that are developing to be able to notify somebody that there are behaviors that are starting to develop that are going to have impacts. So my point in all of that is to say, specifically on the last one that you mentioned, right? Challenge that idea. Is a dashboard showing you those numbers in real time really what you want, or is it a secondary or tertiary effect of that what you're getting after? And I think it's the latter. So there might be a way to I don't want to say circumvent, but there might be a way to get to the end goal or follow a different path to the end goal.
So less about give me a window into what my throughput is if I'm a bottling manufacturer or whatever, and I'm making bottles. Don't just show me I'm pushing out 865 bottles a minute. Show me that there's a potential problem that's starting to occur and my throughput is not now matching the set point in a rate that I would expect, and I'm potentially about to have a throughput reduction, right?
Yep.
And maybe take it one step further, give me some prescriptive responses on how I can fix that, right?
Exactly.
Yeah,
Yep.
really, really cool stuff. Well, as always, Andy, great information. I think we're just about out of time. Don't forget to like and subscribe on YouTube. And for our podcast listeners, feel free to check out the YouTube channel if you want to see the video version of what you've heard today. See you next time.